if a dice is rolled twice, the probability that an odd number will follow an even number is. So these are those two roles, and I have marked it A and B. So this is the first role, and this is the second role. Now the question is the probability that an odd number will follow, which means that in the second role you must get an odd number, and the first role you must get an even number. That is the required condition. Now I need to find the probability for this. So I know that the first role I have to get either 2 or 4 or 6. So the probability out of 6 different options, I am restricting myself to 3 different options because I have 3 even numbers. So the probability of getting an even number in the first roll will be 1 by 2. Right. The first roll, the probability of getting an even number will be 1 by 2. Now in the second roll, I must get either 1 or 3 or 5, which means that again the probability is 1 by 2, the probability to get an odd number. Now this is the first roll, this is the second roll. Now I have to get this as, right, I have to get the first roll as an even number and the second roll as an odd number. So I have to make sure that this happens and this happens, which means that I am actually going to take P of A intersection B. I am going to take P of A intersection B, simultaneous occurrence of event A, which means that the first roll is I get an even number, and the occurrence of event B, which means that I am going to get an odd number. So I have to get the simultaneous occurrence of A and B, which means that is A intersection B. Now, since that these two are independent events, I can say that it is P of A into P of B, which means that I have to take the product of these two things, which means that my answer must be 1 by 4. 1 by 2 into 1 by 2 is 1 by 4. An examination consists of 2 papers, paper 1 and paper 2. Now, the probability of failing in paper 1 is 0.3 and that in paper 2 is 0.2. Given that a student has failed in paper 2, the probability of failing in paper 1 is 0.6. The probability of student failing in both papers. So P of 1, I have used the symbol 1 to denote the failure in paper 1. 2 is the symbol for failure in paper 2. So P of 1 is 0.3 as given the question. P of 2 is 0.2. And P of 1 given 2. Given that the student has failed in paper 2, the probability of failing in paper 1 is 0.6. Now, directly you can say that, though it is not required for this problem, directly you can say that here P of 1 intersection 2 is not P of 1 into P of 2, right? Because it must be when two events are independent, P of 1 given 2 will be P of 1 itself. So it is 0.6, which is not 0.2, 0.3. Now P of 1 given 2 can be written as P of 1 intersection 2 divided by P of 2. What it means is that the probability of failing in paper 1, given that the student has failed in paper 2, which will be equal to probability of 1 intersection 2. It means that this has to happen, event 1 has to happen, and event 2 has to happen. Event 1 is nothing but failure in paper 1. Event 2 is nothing but failure in paper 2. So it is the simultaneous failures in both paper 1 and paper 2 divided by P of 2, which means that failure in paper 2. So this is something which I need to find out, because the question is the probability of student failing in both papers. So this is the simultaneous occurrence of two events, 1 and 2, which means simultaneously he fails in both papers. Now this is given as 0.6. So I know that the numerator is P of 1 intersection 2 divided by P of 2 is 0.2, and this is 0.6. So if I take 0.2 to the side, I know that my required answer will be of 1 intersection 2 will be 0.6 into 0.2, which is 0.12. Consider two independent random variables x and y with identical distributions. The variables x and y take values 0, 1 and 2 with probabilities 1 by 2, 1 by 4 and 1 by 4 respectively. What is the conditional probability P of x plus y is equal to 2? The given condition that x minus y is equal to 0. So we know how to write a conditional probability. based on intersection. So P of x plus y equal to 2, given that x minus y is equal to 0 is nothing but P of this intersection, this, which means that simultaneous occurrence of these two events divided by probability of the condition which has already occurred. So the given condition is x minus y is equal to 0, which means that x and y must be equal. Now you have to find this condition probability. This is the equation for finding that condition probability. Now, the first thing I need to find is this probability. Again, along with that, I have to find this probability. If I take the ratio, I'll get the condition probability. So the first thing is I have to find the probability that P of x minus y is equal to 0. This is what I need to find. P of x minus y is equal to 0. So x minus y can be 0 if x and y takes these values. Either both are zeros, both are ones, both are twos. Right. So 0, 0 is an option, 1, 1 is an option, and 2, 2 is an option to get this condition. The condition that x and y are equal, or x minus y is equal to 0. Both are same. So this has already happened. So that is why I have written that in the denominator. So I'll be finding the probability that x minus y is equal to 0. So 0 happens with the probability 1 by 2. So these two are independent events. So x has to be 0 and y has to be 0, which means that x takes a value of 0 with a probability 1 by 2. Y also takes a value of the probability of getting 0, the probability 1 by 2. So the simultaneous occurrence of these two probabilities will be 1 by 2 into 1 by 2 because they are independent events. I can directly take the product. So it is 1 by 4. Now for both these things to take value 1, 1, it will be 1 by 4 into 1 by 4. 1 by 16. This is also 1 by 4 into 1 by 4, which is 1 by 16. Right. So this is 1 by 4 can be also perceived as 4 by 16. So I have to add these three things, right? Either it can be 0, 0 or, so I am going to add that, or it can be 1, 1 or it can be 2, 2, which means that I have to add these three things, which means that my probability will be 4 by 16 plus 1 by 16 plus 1 by 16. So my denominator will be 6 by 16. I add these three things, that's all. 4 by 16 plus 1 by 16 plus 1 by 16 is 6 by 16. In the numerator, I have to find the probability of simultaneous occurrence of x plus y is equal to 2 and x minus y is equal to 0. So x plus y can be 2 if this is 0, this is 2. This is 2, this is 0. This is 1, this is 1. But I have to make sure that these two things happen simultaneously because I have taken the intersection. The equation for finding conditional probability says that in the numerator, I have to find the simultaneous occurrence of that condition which is given or that thing which has already happened. That is what you mean by giving a condition. So in the numerator, I have to find the probability of simultaneous occurrence of that condition which has happened along with the probability which we are supposed to find. Right. So simultaneously these two things must happen, which means that x plus y must be 2 and x minus y must be 0. So in this particular case, x plus y can be 2 but x minus y cannot be 0 because they are different. In this case also they cannot be 0. X minus y cannot be 0. But in this particular case can be 0. Which means that 1, 1 is the only favorable outcome when I consider the intersection of x plus y is equal to 2 and x minus y is equal to 0. So the probability of getting 1, 1 is nothing but 1 by 4 into 1 by 4, which is 1 by 16. So 1 by 16 divided by 6 by 16 will be 1 by 6. Which means that my answer will be 1 by 6. A fair coin is tossed 10 times. What is the probability that only the first two tosses will yield heads? So I have 10 tosses. I have a fair coin and I am tossing it 10 times. And the question is, what is the probability that only the first two tosses will yield heads? So this must be a head, this must be a head, and the remaining must be tails. The remaining must be tails. That is also implied in that question. The question is, what is the probability that only the first two tosses will yield heads? which means that only these two must be heads and these things must be tails, right? So tail, 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 tail and tail. Now I need to find the probability for such a thing to happen. So for this thing to be a head, I know that the probability is 1 by 2. Again, for this thing to be a head, I know that the probability is 1 by 2. Now for this to be a tail, it is 1 by 2. Like that, if I go on writing like this, for each of these tosses, the probability will be like this. Now, I have to make sure that this is a head, and this is a head, and this is a tail, and this is a tail. I don't have a different option, which means that all these must happen, which means that this must be a head, and this must be a head. It's not that or, is and, which means that I have to take the product. So this is 1 by 2 multiplied for 10 times, which means that my answer will be 1 by 2 raised to 10. Now, you can also think about the same question in a different manner. You have 10 different positions. Each of these positions can be filled in 2 different ways. This can be filled in 2 different ways, right? So I have actually 2 raised to 10 different options. 2 raised to 10 different options of getting a sequence like this of head and tail. I have 2 raised to 10 different options of getting a sequence with head and tail, of which this is just one such option of the different 2 raised to 10 options which I have. This is only a single option out of a set of 2 raised to 10 different options. This is one such option. This is unique and this is a single option. So 1 by 2 raised to 10 will be the answer. You can find the answer either by directly multiplying the probability of individual occurrence, or you can find the total number of possible outcomes and the number of favorable outcomes. I have only one favorable outcome out of 2 raised to 10 different options, which means that my answer will be 1 by 2 raised to 10. A fair dice is tossed 2 times. The probability that the second toss results in a value that is higher than the first toss. So I need to find the probability that the second toss I get a value higher than that I got in the first toss. So if I got 1 in the first toss, then for the second toss I am representing A as the first toss and B as the second toss. Now if I get 1 as the value in the first toss, then if I get 2 or 3 or 4 or 5 or 6, my required condition is satisfied. Like that, if in the second toss if in the first toss if I get 2, then for the second toss I can have options like 3 to 6. Now if it is 5, the only option that I am left with is 6. So this is a favorable outcome, this particular combination. This is a favorable outcome. All these are favorable outcomes. So either this thing must happen, or this thing must happen, or this thing, or this thing, or this thing, which means that I have to take the sums of, right, I have to add these probabilities. Now I have to make sure that in the first toss I get a 1, which has a probability of 1 by 6, and I get 2 or 3 or 4 or 5 or 6, which means that I can have out of 6 different outcomes or options, 5 are favorable, means that is 5 by 6. Now in this particular case, I have to make sure that I get 2 and I get something, a value which is 3 or 4 or 5 or 6, which means that out of 6 I have, when I roll a die, I'll be having 6 different possible outcomes, of which 4 are favorable. Now in the next case it is 1 by 6 into 3 by 6, 1 by 6 into 2 by 6, and 1 by 6 into 1 by 6, right? I must get 5 and I must get 6. So 1 by 6 into 1 by 6. These are the only favorable outcomes that I have. Now I have to sum these things, which means that I'll take 1 by 6 into 1 by 6 as the common factor, which is 1 by 36, into 5 plus 4 plus I have to add these 3 things, these 5 things, right? 1, 2, 3, 4 and 5. So 3 plus 2 is 5 plus 1 6, 6 plus 4 10, 15. So this is 15. So this is nothing but 5 divided by 12. So my answer will be 5 by 12.